In today's video, I want to show you how I went about solving exploit number 1, ETHERSTORE, found here on the Solidity Challenges repo. So in order to get started, simply clone the repo and then open it up in your preferred editor. I'm using VS Code. Now, the README file for ETHERSTORE states that the ETHERSTORE is loaded with funds, but its implementation is flawed. Uncover the vulnerability and drain all the funds. Okay, so we'll start by going to the ETHERSTORE contract and we'll just assess it from top to bottom. So in the beginning here, it looks like they've set up a balances mapping, and then they allow us to deposit against that mapping, just passing the value that we give it. So nothing out of the ordinary yet. At the bottom, we have another single line function, and it's just a simple getter, so we can disregard that at the moment. All focus should be on the withdraw function. Now here, looks like they're simply grabbing the balance of the mapping and storing it in a variable, then checking against that variable to ensure that the balance is greater than 0. If it is greater than 0, they're going to take that user's balance and they're going to send it to them. They're going to use call, and you can see here that there's no method, so that's going to go directly. If it's EOA, it'll go directly to them. If it's a contract, it will hit the receive function if they have one. And if that's successful, then their balance will be updated in the mapping. Okay, so I hope you caught it. It's pretty straightforward as far as exploits go. It's the checks, effects, and interactions not being applied. We're making an external call, and then we're updating state. That is backwards, and many exploits have happened because of this. So when we don't do this, the value that we send, if it's not an EOA, will be a smart contract. And if that value is handled maliciously, they will re-enter back into this contract and withdraw more and more. And they can do that because as far as the ETHERSTORE is concerned, that we have a balance, because we haven't gotten to this point where we've actually updated the balance. We're still up here, kind of hijack the flow, and we're not going to stop until we drain or siphon all the funds. And only then will we stop and let the ETHERSTORE continue its logic. All right, so let's see that with an attack contract. All right. My attack contract will do exactly that. So let's just kind of clean the page. All right. So to create an attack contract, I just imported ETHERSTORE. I created an instance of it in my constructor. I have my receive function and my attack function. So we'll start with the attack function. In order to kick this attack off, we need to have a balance over here on ETHERSTORE. So I will call deposit and pass in 1 ETH. Now that I have a balance, I'll call withdraw. And like we said, we're going to withdraw, and then that value is going to be sent back to us. Our receive function now will pick it up, and the trigger withdraw method will do the reentrancy. It's going to check to ensure that there is a balance that's equal to or greater than 1. And if there is, we're going to withdraw. And every time we withdraw, we're going to be withdrawing what our balance, what the ETHERSTORE believes to be 1 Ether. So if it had 5 Ether, then we would withdraw. We deposited 1, so it would have 6 Ether. And then we would withdraw 1, and then it would send it to us. We would re-enter, withdraw another, and have 5, 4, 3, 2, and then 1. We would be doing a check here the whole time to ensure that there is a balance indeed on the ETHERSTORE. Because if there's a balance of 0 and we try to withdraw, well, then it's actually going to trigger this revert. Right? It's going to not pass the guard, and then our attack will not work. So that's really the only check I needed to put in place to ensure a successful attack. All right, so let's see this in action through our unit test, and then we'll run it in the terminal. All right. ETHERSTORE.t.sol. I started by importing the attack contract, and I'll go through how they structured this particular test. They have the contract, and they have 2 EOAs, store owner and challenger. The store owner has been dealt 10 Ether, and the challenger has 5. They deployed the ETHERSTORE and gave it a value of 5. Okay. There's a pre-check just to ensure that the value or the balance of the ETHERSTORE is indeed 5 Ether. Down here is where they want us to run our attack logic. And you can see my logic is simply 3 lines of code. I deploy my attack contract, then I call attack with 1 Ether. And as I showed you, this calling attack triggers the whole reentrancy attack flow. So in the end, if successful, this assertion should be true that the balance of the ETHERSTORE is indeed 0. All right, moving over to the terminal, I've preloaded the command. And when we run it, we can see exactly that. We can see a successful reentrancy attack, and it really does print out quite nicely. So looking at it here, you can see we have our attack contract deployed, and then we call attack, and we pass in the value, and that will go to the ETHERSTORE contract and run the deposit. So now we have our deposit, and then right away, as soon as we're done with the deposit, we called withdraw. And this is where we re-enter like 5, 6 times here. So by calling withdraw, it called our receive function, which then re-entered back in and called withdraw, which called receive. So, and withdraw, receive, you get the idea. Okay. And then we made sure, running our check the whole time, that there was always a balance on ETHERSTORE. And as long as there was, we were going to siphon a little more until we were satisfied. And we would stop. And then in this case, the numbers were all, manufactured to work and give us a nice, easy 0 balance. So here we can easily assert that the ETHERSTORE balance is indeed 0. All right, so that was my approach to solving the ETHERSTORE challenge. So if you had any questions with the way I approached it, or perhaps you have a way of approaching it differently, either way, feel free to reach out. You can find my contact information in the comments below. See you in the next one.